This is an example of a projectile launched at an angle and is launched at a particular target. Football is kicked at an angle of 47 degrees with a velocity of 25 meters per second. The football has to travel at least 50 meters in order to have a chance to go over the crossbar, which is 2.5 meters in height. We will then assume the football makes the distance. If it does not, the y direction will tell us. We start off in the x direction and remind ourselves that we have d is equal to vt. We'll put our y direction over here. Since we have a 25 meter per second launch at an angle, we have to break this into our x and y velocities before we can calculate. This would be our vy. This one would be our vx. So we can say the sine of 47 is equal to vy over 25. Vy is 18 meters per second. Cosine of 47 equals Vx over 25. Vx is 17 meters per second. Now moving to our displacement in the x direction, we're going to put 50 meters in for that. And again, if it doesn't travel 50 meters, information in the y will let us know. Velocity is equal to 17 meters per second. Time is not known, but it can be easily solved for since we have a displacement and a velocity. Substituting into this equation, we have 50 is equal to 17t. T is equal to 2.9 seconds. Let's place that in our chart above. We now turn to the y direction because we need to figure out how high the football is when the football travels 50 meters in the x direction. So we start off, velocity 1 is going to equal our 18 meters per second already solved for. Velocity 2 is not known, and we're not going to need to know it for this question. Acceleration is negative 9.8 meters per second squared. Time, as previously calculated, is 2.9 seconds. Displacement is not known. Now it's tempting to put 2.5 in for the displacement, but remember the 2.5 refers to the goalpost. It does not refer to the football. We do not know how high the football is when it gets to the goalpost. That becomes our unknown in this equation. Once again, we can choose the equation that does not have velocity 2 in it. D is equal to v1t plus 1/2 at squared. Displacement is equal to 18 multiplied by 2.9 plus 1/2 negative 9.8 times 2.9 squared. D turns out to be 11 meters. What that means is the football will be up here somewhere when it reaches the goalpost and is definitely above the 2.5 meters of the crossbar. As long as the football will go in between these two posts, we assume that the field goal is good.